Hello there, this is an Algebra 2 video. It is Chapter 8, Section 5, and today we will be discussing variation functions. Now we did do some variation in Algebra 1, and so I don't know how much of that you might recall, but here we have some vocabulary for you to get started. A direct variation can be expressed in the form y equals kx. So here's the equation there, which is a linear equation. In this equation, the k is what we would call the constant of variation, or the constant of proportionality, as oftentimes it is called. A direct variation is a special case of an equation that is written in slope-intercept form. You recall y equals mx plus b linear. If you were to take the m, which is the slope, and we equate that to k, which is the constant of variation, and if we assume that the b value, which of course you might remember is the y-intercept of a linear equation, if that y-intercept happens to be 0, then you can take y equals mx plus b, and all of a sudden it becomes y equals kx. So y equals kx is a form of a linear equation with the stipulation that the slope is the direct variation, or the constant of variation. So that's one thing. The other thing is that because there's no b, all direct variation equations will pass through the origin, because the y-intercept will be 0, and so therefore 0, 0. So that's another item of interest. So to express a direct variation, we usually say that you will say something like y varies directly as x. That's one way that we express it. Or in other words, it's basically saying that as x increases, y increases or decreases at a constant rate. So here we have, just in a summary, what a direct variation looks like. We have that it's y varies directly as x. If there is some non-zero constant k, obviously k can't be 0, otherwise you wouldn't have a direct variation. So the equation is y equals kx. And so what I want to show you next, before we go into the example, is what we can do when we know that something varies directly with something else, and if you're given some information. So if you know that y varies directly as x, and if you're given a set of values, then you can use the proportion to find the other set of corresponding values. For example, let's say that you had 2 points. So let's go here with, let's say you had x1, y1, and x2, y2 as an example. And you wanted to, and you know that it's a direct variation, then you can write that y1 will equal k times x1, because that's the direct variation, y equals kx. And so in the case of x2, y2, you could write y2 equals kx2, like that. And if you wanted to solve for k in either case, in this case you would divide by x1 on both sides. In this case you would divide by x2 on both sides. And the idea here is that the k, because it's a constant of variation, should be the same for both pairs of points, or for both values. Therefore, we can equate that this k should equal that k, and since here this cancels, then k equals y1 over x1. And in this case, these cancel, and you get that k equals y2 over x2. And so now you have a proportion, which is why sometimes when I said earlier that it's either called varies directly, or it is directly proportional, is another way of saying it. The constant of variation, or the constant of proportionality, we use that word a lot because you can set up a proportion here, and then you can solve this proportion for a missing value, which is what we're going to do in the next, or in the first example here. So in example 1 says, if y varies directly as x and y equals 15 when x equals -5, find y when x equals 7. So based on what we just had up there a little while ago with our proportion, we know that y1 is to x1 as y2 is to x2. And so we can just fill in what we know. We can take our points and use the first one as our first order pair, so we can say y equals 15 could be our y1, and then x equals -5 could be our x1. And then over here, find y, well, this would be our second y, and then this would be our second x. So we just plug our information in. So we have y1, which is 15, is to x1, which is -5, as y2, which is what we don't know, to x2, which is 7, and then we can solve this. Now you can choose to reduce fractions beforehand to make your life a little bit easier. So we know that 5 goes into 5 once, 5 goes into 15 3 times, and now we can do the cross multiplication, 7 times 3 being 21, and y2 times -1 being -y2. And so in the end, if you divide both sides by -1, then y2 will equal -21. And just like that, we have found the value of y2, which is what we were being asked to find. So now you can do the same, use the same proportion to figure out do-it-yourself number 1. Then we will go on to another type of variation, which is joint variation, which means just that. Joint variation means like together, right? You join things together. Occurs when one quantity varies directly as a product of 2 or more other quantities. So instead of just having y equals kx, you could have something like y equals k, x, and z. So there's 2 variables there. Again, k is a constant, but x and z are both variables. But in a very similar fashion, if we have y equals kxz, we can pretty much say that, let's go back here, that y1 equals k x1 z1 in this case, because we have x and z, right? And then you could have y2 equals k x2 z2, just like that, and do the same thing. We're going to basically solve for k. In this case, when you solve for k, you divide by x1 and by z1 on both sides. So we get that k will equal y1 over x1 z1. And that's basically the fraction that you end up with. In this case, you're going to get much the same thing, only with little 2's instead of 1's. Divide both sides by x2 z2. These cancel. And on this side, we're going to get y2 over x2 z2. But because, again, both k's should be equal, we get another proportion. And this time, our proportion looks like this. y1 is to the product of x1 and z1, as y2 is to the product of x2 and z2, just like that. And we're going to use that proportion to solve for our example 2 here. So in example 2, as I said, we're going to rewrite that so we don't get confused here. y1 is to x1 z1 as y2 is to x2 z2. And for example 2, it tells us, suppose y varies jointly as x and z. Find y when x equals 9 and z equals 2. So we're going to go ahead and again, we're going to say this is our y1, x1, z1. And then we're going to go here if y2 equals 20, when z2 equals 3, and x2 equals 5, and just plug in our stuff. So for y1, that's what we're trying to find. But x1 is 9 and z1 is 2, so we're going to go 9 times 2 there. And then y2 is 20, and then our z2 is 3 and our x2 is 5, so 5 times 3. And again, if you want to simplify some stuff before you get started, we know that 5 goes into 5 once and 5 goes into 24 times. So we actually have 3 times y1 equal to 9 times 2, which is 18, and then 18 times 4, which is actually 72. Divide both sides by 3, and our y1 is going to equal 24. And there you go. So again, using the same proportion, you want to do it yourself number 2, and then we will go on to inverse variation. and inverse variation. If two quantities, x and y, show inverse variation, that means that their product is equal to a constant k. And we'll show you how that works here with in a second, but I wanted to give you an example. Inverse variation is often described, we said earlier that one quantity increases while the other one is also increasing or decreasing, but in the case of inverse variation, it's when one quantity is increasing while the other quantity is decreasing. An example of that, which is pretty easy to understand, is speed and time for a fixed distance. The faster you go, so your speed is increasing, the less time it takes you to get there, so your time is actually decreasing. That's one example of how this can happen. But in the end, what it looks like is instead of having joint variation where it's y equals k and then x times z, in this case, when you have inverse variation, think of the inverse of multiplication, which is division. And so you'll end up with y, why do I keep doing that? Can't write on the board yet. Y equals k over x, like that. As opposed to having k times x, or k times x times z, you now are dividing by x. But again, we can set up a proportion quite easily. We can say that this is y1 equals k over x1, and then of course if you have a second point or second pair of values, you could call that y2 equals k over x2. And to solve for k this time, you need to multiply by x1 on both sides. And so we get that k is equal to x1 times y1, hence why it says the product is equal to a constant k. So their product is equal to k. And so over here you get the same thing, the product of x2 and y2. So in this case, we don't necessarily get a proportion, but we know that x1, y1 should equal x2, y2. And you could make it a proportion if you put it like that. But there you go. So we're going to use this little equation to do it yourself, or to do example 3. So to recap here, we want to say that x1, y1 equals x2, y2. And so we're going to say here now we have, instead of x1, x's and y's, we're doing a and b. So if we want, just to make things easier, we can actually modify our formula. And instead of saying x1, y1, which we're using a and b, we could just use a1, b1 equals a2, b2. Just so that we're not confusing ourselves. And so here we have that a1 equals 28 and b1 equals -2. They want us to find a2 when b2 equals -10. So we just plug in our information. So for a1 we're going to get 28, b1 is -2, and then for a2 that's what we're actually trying to find, but b2 is -10, so we get -10a. We just divide both sides by -10 in this case. And a is going to equal, well, 28 times -2 is -56 divided by negative, we get a positive 28 fifths. And there you go. Just like that, you've done example 3. And so now we're going to use that same formula. Of course, in part do example 3, you're going to want to use x1 and y1 because the variables are x and y. But other than that, it's going to be the same idea. So we're going to go to our word problem here. And here is where I kind of want to make sure that you're understanding how to translate from a word problem to the algebraic meaning. So one of the things you're going to have to do is just choose some variables that work for you. You don't have to choose the variable that I'm using, but it just makes it easier for me to use the variables that I'm using. So for example, it says the length of a violin string, and here's our key phrase, varies directly. So I'm going to have variable k and then another variable. And it says inversely, so it's going to be y equals k over x. But I don't necessarily want to use y and x because that's not the variable that was given. So here it's talking about length of the violin string. So I'm going to go ahead and go with L. And L equals some form of k because it says it varies inversely. And so inversely means I'm going to have division, and so it varies inversely with what? That's the variable that needs to go on the bottom. And it says that it varies inversely with the frequency of its vibrations. So I'm just going to use F for frequency of vibrations. And then I can go ahead and just do L1, F1. And so I know that my K value is going to be L1 times F1 is going to equal L2, F2, if you will. And so in this case, it tells me that a violin string, again, that's the length, is 10 inches long. So that would be my L1. And then the vibrations are 512 cycles per second. So I replace F1 with 512. And then it says, find the frequency. So I don't know the F value, but I do know that it's 8 inches. So my L is going to be 8. And I don't know what that second frequency is. So I just divide both sides by 8, and 10 times 512, and then divided by 8 is actually going to give me a frequency of 640 cycles per second. Awesome. Now, so we're going to use that concept so that you can do it yourself, number 4. And then we're going to go to our last type of variation, which is combined variation. And in combined variation, you basically have both types of joint and inverse variation going on at the same time. So it says here, combined variation occurs when one quantity varies directly and or inversely as 2 or more quantities. So for as an example, you could have something like, instead of y equals kx and then z, which is what we already did in joint variation, you could have y equals kx over z. So you've got some direct variation going on and some inverse variation going on with the z variable there. So if you had something like that, again, you could just make these all ones, y1 equals kx1 z1, and then you would have y2 equals k x2 z2, like that. And to solve for k, you would have to multiply by the reciprocal of these two things. So to get rid of the x1, I need to put x1 on the bottom. To get rid of the z1, it needs to go on top, and you need to do the same thing to the other side. And over here, same thing, we're going to multiply z2 over x2, z2 over x2. So it turns out that my k value is going to actually, when the x's cancel and the z's cancel, you're going to get y1, z1 over x1 in this case. And over here, you're going to get those to cancel, they're going to cancel. So your k is going to equal y2, z2 over x2. And so your proportion is going to look y1, z1 over x1 equal to y2, z2 over x2. So that's the proportion you're going to be working with for a combined variation. And so we're going to go to our last example here and apply their formula to solve it. So in example 5, it again has different variables. So I'm going to go ahead and kind of go with what variables are given here. So f varies directly as g. So if f varies directly as g, that's what you would have. But it says also, and f varies inversely as h. So I get that. So in order to get my k, I have to multiply by h over g on both sides, so they cancel. So my k is going to equal to, I like to go in alphabetical order here, so f1, h1 over g1, which means that my second pair of values will be the same thing but with 2's. So my formula will look a lot like f1, h1 over g1 equal to f2, h2 over g2. And so now we're going to go here, just find g So we're going to look for G1 when F1 equals 18 and H1 equals -3. If G2 equals 24, when H2 equals 2 and F2 equals 6. So we're just going to plug everything in. So our F1 is 18 and our H1 is -3 and our G1 is what we're looking for. And then our F2 is 6 and our H2 is dose and our G2 is 24. So again, before we do anything else, we probably want to reduce some things. So we know that 6 times 2 is 12, and 12 goes into 12 once, and 12 goes into 24 twice. So now when we do our cross multiplication, we get 1 times G1 is just G1. And then 2 times 18 times -3, or you could go 2 times -3, which is -6, and -6 times 18 is actually -108. So our value for G1 is -108. And just like that, you have finished example 5. And so now using that same concept, you want to do it yourself number 5. And once you have completed this do-it-yourself question, you will have completed your notes for this lesson, and I will see you in class, and thanks for watching.